Alright, so we're back continuing with dihybrid crosses that Miss K started going over. I'm going to show you guys one method, which is going to be setting up two separate Punnett squares and kind of going through and multiplying them with the probability. Miss K is going to show you the long 16 Punnett square box formula. So if we're looking at our original problem that we were looking at, remember we're looking at two traits at the same time. I'm still on the front page here looking at Mendel's plants, and he's crossing something that is homozygous round yellow. If you go back to that coloring packet, you guys should see the second page in talks about Mendel's plants, and it does say that round is dominant to wrinkled, and we're looking at seed shape there. So we want to set up a key for that particular trait, whether they're round or wrinkled, and the second thing is the color, whether they're yellow or green. As you guys are looking at the problem, I know that yellow is going to be dominant over green. You can look on that second page where it will say yellow is dominant over green for one of the particular traits. If you're still not sure, green says that we're dealing homozygous recessive for wrinkled. So I know that wrinkle's recessive, but this homozygous recessive also is dealing with green, just describing both of these traits. So I know that green is going to be my recessive to yellow. So the first thing I want to do is I want to set up two separate keys. I want to set up a key for my shape, and then I want to set up a key for my second trait, which was color. Give yourself letters. So I'm going to use R's for my shape. I know that big R, my homozygous dominant, is a round. Big R is round. Little r is a wrinkled seed. Now if I look at color, I'm going to use G's. Big G is yellow. Big G is yellow. Little g is going to be my green seeds. So I have two separate keys now. It's still step one. I'm still doing all 5 steps like I normally would. So now I want to go through and I want to look at my parents. So I have two separate parents. My first parent here, the one that is underlined in red in the problem, says that I'm dealing with homozygous round yellow. So my homozygous round, two of the same, is going to be big R. He's also homozygous yellow, which means that he's also big G. Parent number 1 has all of those particular letters together. Parent number 2 is homozygous recessive wrinkled. We have little r, but we're also homozygous recessive green. They're also little g. So that's showing parent 1, that's showing parent 2 for both of those traits. In order to do two separate Punnett squares, I want to separate those traits out for both of my parents though. So if we're continuing looking at that particular problem, I want to say, okay, well, what does parent 1 and 2 look like just for shape? So if I'm pulling it out, I say parent 1 is big R, parent 2 is little r. This you know how to do from there. We've done this. We did this in our last lesson on video. If we're looking at color, parent number 1 is big G. Parent number 2 is little g. I'm just placing my letters together now. So I'm dealing with one trait here for both parents, one trait here for both parents. Go through and do your steps from there. That was step 2. That was my parent cross. I'm going to do a Punnett square for each. So one parent goes across the top, one goes down the side. I don't care which way I put them. So I could have put little r here, big R here. You're dropping in, you're filling in, you're figuring out that F1. When we do that, we can say that all those F1s are going to be big R, little r. It's the only choice that we possibly can have. Same thing with our big G's and little g's over here. One parent is big G, one parent is little g. All my F1s are little g. Step 4, genotypic ratio. Write them out. So it could be either big R, little r. That's what we have in our key. Go back and count them up. I just said all 4 of them are going to be big R, little r. So I have 0 that are little big R. I have 0 that are little r, and all 4 are big R, little r. Same event for our G's over here. So all 4 of them are big G, little g. Phenotypic ratio. They're either going to be round or wrinkled. Well, I don't have any that are big R, but I do have 4 that are big R, little r. That means that they're going to be round. None of them will be wrinkled. So if that were the case, I would not be able to produce any wrinkled seeds with this particular parent cross. Same thing with color. I'm not going to be able to make any greens because all 4 offspring are big G, little g. But we can't stop there because we want to know both traits at the same time. Right now we're saying, oh, this is what we have for one trait and this is what we have for the other trait. But how about if we put them together? And that's where we're going to come back into that probability. So we want to know what plants do we have that can be, and let's look at our traits together, combine them. What plants can be round and yellow? What traits can be round and green? What plants can be wrinkled and yellow? Which ones can be wrinkled and green? So we're trying to combine these traits together. I usually write them out just like that. So I'll kind of have them and I'll list them just like what we just said. My two dominant choices, round and yellow, dominant recessive, round and green, wrinkled for shape and dominant for color. So we have wrinkled yellow, and then my two recessive choices, wrinkled and green. And then I just throw in my phenotypic ratio. The only difference I did on my phenotypic ratio here is keep them in fractions. So I have 4 out of 4 that are there. If I had 1 out of 4, I would put 1/4. If I had 2 out of 4, put 2/4. Keep your phenotypic ratio in fractions to make the next part a little bit easier. I'm going to fill them in. How many were round? Oh, 4 out of 4. How many were yellow? Oh, 4 out of 4. You're going to multiply them through. That's that probability that we were talking about where you're just multiplying them through. So I know that all 16 out of 16, every plant that is created here is going to be round and yellow. Go through and look at the rest. How many are round? Still 4 out of 4. How many are green? I don't have any. So anything times 0 is going to give me 0. And that's the case for the rest of them as well if you guys look at them. I always add them up. Make sure that my numbers here equal 16. Okay, because if I get an 18 or a 20, maybe I multiplied wrong somewhere along the line. This particular cross will give you a probability of 16 total offspring. So this now is my F1 generation. I could say go ahead and make an F2 generation now. So you would go, okay, to make that F2 generation, I'm just crossing my offspring for my F1s. So when we look at that, we're going to go ahead, we're looking at my key. I'm doing the key again now. So it's the same exact key. I'm still looking at shape. I'm still looking at color. My round is still dominant over wrinkled. Yellow is still dominant over green. However, when I now go to my parents, I said I am crossing 2 of my F1s. My F1s were all big R, little r, big G, little g. If they were a mixture and you didn't know which ones to pick, you're just picking any two and kind of combining them together. Here, they're all the same. I only have one possible choice. I'm going to cross big R, big G, little g. My second parent is going to be big R, big G, little g. Same thing, keep your traits together. So let's look at the traits for shape, and then we'll do a cross just for color. So I want to separate them out. So my parent 1, my parent 2. Parent 1 is big R, parent 2 is big R. That is for shape. If I'm going through for color, one parent is big G, little g. My other parent is big G, little g. Do your Punnett squares, just like we've been doing. So there's my Punnett squares for them. One parent across the top, one parent along the side for both of them. Fill them in. These guys now are those F2 generations on both. These are my possible offspring for that second generation. Once again, these are separate traits. I want to put them together. Genotypic ratio. 1 big R. I have 2 that are big R, little r. I have 1 that's little r. Same thing with my colors. Big G, I have 1. Big G, I have 2. Little g, I have 1. So put in a ratio. I have a 1 to 2 to 1 ratio for both of these particular traits. Now I want to look at physical appearance on them. So my phenotypic ratio. Big R and big R, little r are all going to be round. So I have 3 out of 4. I have 4 possible offspring. Keep it a fraction. I have 1 out of 4 that's wrinkled, and that's my little r. Same with my colors. Big G, little g will be yellow. Little g will be green. So 1 out of 4, 3 out of 4 there. Now start putting them together again. How many can be round and yellow? My two dominant choices. How many can be round and green? Dominant, recessive. How many can be wrinkled and yellow? Recessive, dominant. And how many can be my two recessive choices? Wrinkled and green. So that's what we're kind of looking at here with all 4 possible choices. And you'll always have 4 possible combinations that you want to write out. So if we're looking at it, that's what you guys have here. So go back up, fill them in. How many are my two dominant choices? 3 out of 4, 3 out of 4. Watch your math. Don't add them together. You guys want to multiply them through. That's that probability law that we talked about. So 3 times 3 is 9, 9 out of 16. Round and green, dominant recessive, 3 out of 16. Wrinkled and yellow, 3 out of 16. Wrinkled and green, 1/4 times 1/4 gives me 1 out of 16. And this is what I said, add them up. 9 plus 3 plus 3 plus 1 is going to give you 16. So here's a little trick for you guys. Whenever you create dihybrids that are heterozygous for both traits, which is what we had, they were heterozygous for shape, they were heterozygous for color, both parents were that. you will always have a 9:3 to 3:1 ratio there. You should always have that ratio. And how you guys may see problems like this, you might say, okay, well, you have 16 offspring, but we're not always going to create 16 offspring. Let's say that we have 64 offspring created. How many of them could be wrinkled and yellow? So you go, okay, well, if I have 64 instead of 16 created, let me go through and think about it. 16 can go into 64 4 times. And this is kind of the problem that I'm looking at. If I had 64 offspring produced, how many are wrinkled and yellow, which is right here? Okay, 16 can go into 64 4 times. So if I had 3 out of 16, I'm going to multiply that by 4. That's going to give me 12 out of the 64 that are produced. So that's usually how you guys are going to see questions asked on that. Not like, oh, if there are 16 produced, but how about if I have more than that? And usually it will be a number that 16 will go into for you guys. So that is the first method that we have. When you guys do these problems, you can do either or method. You don't have to do both methods. So as Ms. K goes through the next method, if you're like, hey, this is a lot easier for certain problems, go ahead and learn that way as well. Okay, we'll be right back with the next method.